When you start your car and hear the engine roar to life, you're listening to hundreds of parts working in perfect harmony. But what really happens under the hood? Today, we're going deep inside a car engine to explore all its important components, how they work, what they do, and why each one matters to the performance and reliability of your vehicle. 1. Cylinder block. Let's start with the foundation of the engine, the cylinder block. This large metal casting forms the main structure and houses the cylinders, coolant passages, oil galleries, and sometimes even the crankshaft bearings. It's built to handle high pressure, high temperatures, and the beating of combustion happening thousands of times a minute. 2. Cylinders, pistons, and combustion. Inside the block are the cylinders, typically 4, 6, or 8 of them, depending on your engine type. These are the chambers where fuel burns. Inside each one is a piston, a solid metal plug that moves up and down due to combustion. When air and fuel ignite, it forces the piston downward, producing power. This up and down motion is called reciprocating motion. 3. Connecting rods and crankshaft. Each piston is attached to a connecting rod, which in turn is connected to the crankshaft. This clever piece of engineering transforms the piston's up and down movement into rotational energy. That rotation is what ultimately powers your wheels. 4. Cylinder head. Now, let's look at the top part of the engine, the cylinder head. It seals off the top of the combustion chamber and contains crucial components like valves, spark plugs, and the camshaft. It's often made from aluminum to reduce weight and help dissipate heat quickly. 5. Valves and camshaft. Every cylinder has at least 2 valves, one for air intake and one for exhaust. Some modern engines have 4 per cylinder for better performance. These valves are operated by the camshaft, which rotates in perfect sync with the crankshaft. Lobes on the camshaft press on the valves to open and close them at precisely the right moments. 6. Timing belt and chain. To keep this whole orchestra in rhythm, the engine uses a timing belt or chain. This connects the crankshaft and camshaft, ensuring the valves and pistons move in sync. If the timing slips, the pistons could crash into the valves, causing major engine damage. 7. Fuel injections and intake manifold. Fuel injectors are tiny nozzles that deliver fuel into the engine with extreme precision. In most modern engines, fuel is sprayed directly into the combustion chamber or intake manifold. The intake manifold, on the other hand, distributes air evenly to each cylinder, helping create the perfect air-fuel mix. 8. Spark plugs and ignition. For gasoline engines, the spark plug is the fire starter. It produces a small but powerful electric spark to ignite the air-fuel mixture. The exact timing of this spark is controlled by the engine computer to maximize power and fuel efficiency. 9. Before combustion can even start, the engine needs to turn over. That's the job of the starter motor. It spins the crankshaft just long enough for the engine to fire up and take over. 10. Cooling systems and radiator. Engines generate intense heat, and without proper cooling, they can overheat and fail. Coolant absorbs the heat from the engine and carries it to the radiator. The radiator then releases the heat into the air, keeping engine temperatures within safe limits. 11. Oil system and oil pump. Just like our joints need lubrication, engine parts need oil. The oil pump circulates engine oil through galleries and passages, lubricating bearings, cams, and cylinder walls. It also helps with cooling and keeps metal parts from grinding together. 12. Air filter and throttle body. Before air enters the engine, it passes through the air filter, which removes dust and debris. The throttle body regulates how much air flows into the engine when you press the gas pedal. More air means more power. 13. EC. Modern engines are smart, thanks to the ECU, or engine control unit. This is the brain of the engine. It constantly monitors sensors, adjusts fuel injection, ignition timing, valve timing, and even turbo boost to optimize performance, economy, and emissions. 14. Turbocharger or supercharger. To increase engine power without increasing engine size, many modern cars use a turbocharger or supercharger. A turbo uses exhaust gases to spin a turbine and compress incoming air. A supercharger does the same job, but is powered mechanically by the engine. More air plus more fuel equals to more power. If you found this helpful, hit like, subscribe, and share this with a car lover like you.